I'm just going to give that a test. Ah, okay. So this was originally like a 30-minute talk. We've only got 15 minutes. So we're going to fly through. I'm going to skip some stuff. So basically, this is kind of like a fire and brimstone speech. It kind of inadvertently became that because it was like, all right, so people who already know about mining but want to like, run a large-scale facility, like, can you kind of talk about like what does the day-to-day look like? I'm like, that's terrifying. There's like constantly putting out fires, and like in some places like literal fires, like so like and the other thing is that you've got all this hardware and like really valuable machinery, like when you run in like dense like GPU farms, like each machine is like upwards of $8,000 per. You've got 8 GPUs crammed into like a tiny chassis, and you're just stacking them up. You got to figure out how to cool them. You got to make sure that you keep like the power working. Oh, also I got another question. Is there a timekeeper or something to make sure I don't go over time?
Go for it. You're good.
Okay. All right. So just kind of jumping into everything. So one of like the biggest issues is like pool compromises and things like that. Like that's why like BlockCypher is super on top of managing the infrastructure and like getting everything like that. There's been like hack after hack after hack. Like we heard about Nice Hash, and that like happened right as I was making this one earlier last year. People get compromised all the time, and it's one of those situations that you should never rely on anybody for holding your funds. It's like the same with web wallets. Like don't keep your coins in Coinbase or on an exchange or anywhere. Try to always get everything to cold storage. Make sure that you distribute things, and it becomes one of those really difficult challenges when you run an operation at scale. Is how do you make sure that all of your investors are getting their payouts, that you are like doing everything that you can to make sure that you're securing their funds. And the first and foremost is trust no one. and kind of operate with that in everything that you do. So in that case too is like you also can't trust yourself. You can't trust your employees. You can't trust anybody. So social engineering is rampant everywhere. Like like our investors have had lots of money stolen. Like VCs, venture capitalists. Like everybody is vulnerable. So make sure that you're always testing everybody, making sure that they know to be wary of random emails from strangers and attachments and things like that, because 9 times out of 10 it's human error that results in the loss of all of your earnings. And I mean the same goes too, is like if you've got a bunch of techs, people operating the day-to-day, is like they're not making a super high wage, like like trust but verify. Make sure that you bake it into the architecture of your build out or your operation to always have it so that everyone can more or less get their job done with the minimal amount of privilege. So they don't have access to like core networking. They don't have the ability to like divert miners to like their own pool and account and start collecting funds on the side. And the other thing is like network security. So basically what I'm doing is I'm going to go through and kind of just give you guys like the high level. So you guys, if you're interested in mining, one, you can talk to us, HashRabbit. We do like mining at scale. We sell mining contracts and things like that. But always happy to help anybody. So come talk to me afterward. Love talking about mining. But DDoS attacks are another huge one. You got to worry about any exposed network surface. You've got to worry about one, how are you going to secure remote access into your network, and how are you going to mine without becoming a huge giant target for everyone in the world. Like one of like the biggest things that we noticed with like new cryptocurrency launches and things like that is if you run a node in your facility, you immediately become a huge target if you start forwarding a port. Because what ends up happening is if like an evil miner, let's say for example, wants to compete with you, well, what are they going to do? They're going to DDoS everybody else to make sure that their nodes can't propagate blocks. Like it only makes sense. Like mining is inherently greedy, and people do everything that they can to make sure that they can get an edge over the competition, even if it's kind of shady. No, it is shady. It's super shady. But like you'll see really kind of like interesting attacks on mining. One of those is like Bgp hijackings. So BGP is the routing protocol that basically core network hardware basically uses to communicate okay, so I have IP address A and I have IP address B. So one way that people have been compromised at the internet service provider level has been those packets being rerouted to a totally separate place. So you start connecting to, say, Grin or some other place, and without anybody being responsible for that, except for your ISP in the middle, they can divert it so that suddenly you're mining on a totally different pool in another region of the entire world. And there's really not a lot you can do to secure against that except using TLS to secure your communications, using certificate pinning. A lot of things we haven't necessarily developed, especially in the Grin community. I think one of the big things is that their protocol for mining, they encourage you to use TLS or encryption out of the box. So that ends up being a lot better than what you see in the rest of the industry. But there's a lot that we can be done to make sure that we know which mining pool we're mining on, that there isn't that kind of malicious impersonation going on. I'm going to take a sip of water. So the other thing is man-in-the-middle attacks, which I kind of touched on briefly. And as far as that goes, one of the biggest things with classic stratum and things like that, and previous attacks and things that usually result in millions of dollars of loss, man-in-the-middle attacks are basically where someone just outright hijacks a connection from underneath you, and that's without doing anything on the BGP sort of routing layer. That can be at anywhere in your facility. Now, you're mostly protected in the case of Grin if you're doing TLS. So yeah, zero protection. But the biggest thing is that Stratum was actually made for, I don't know if anybody's familiar with Electrum wallet. It was one of the first SPVs for transacting Bitcoin. So Stratum wasn't even made for mining. It was made so that you could transact Bitcoin without having a full copy of the blockchain. Very similar, right? So it got repurposed and turned into a mining protocol because it was just close enough in the communication mechanism that they just kind of kept it. And a whole industry, and then some, has just built on top of it. It's the Wild West. There's no standards. No specifications. It's really the early internet over here. Nobody's really stepping up and trying to define a standard, something that's interoperable, that's easy to implement, that's consistent. I'm really sorry, Catherine, for all the trouble you guys had to do and go through implementing a protocol that's not specified. You kind of just end up in this situation where you're doing what you think is right, but your clients at the end of the day are going to implement something totally different. And we're all stuck with it indefinitely. Like I said, fire and brimstone. Everything's terrible. Nothing will get better. But at the end of the day, trying to fix a lot of these flaws, it ends up feeling like you're just putting another Band-Aid on top. We've just strapped TLS on top of Stratum and called it a day. And Grin Stratum isn't really Stratum. It isn't even, sorry, this is getting more technical, but JSON RPC, it actually breaks a lot more things than it fixes. At the end of the day, it gets it done, and proof of work works, and the network works. It's just one of those things that you end up with another conflicting standard with a similar name that implements something totally different. But I'll give them an earful. So the other thing is when people talk to me about mining rigs, they're usually oh, so what's a miner look like? And you're well, it's like a box with it's really hot, it's really loud. Okay, so they're servers. No, they're not. They're kitchen appliances. They do one thing. They're not serving customers. They're not Amazon servers doing e-commerce and this and that. No, they perform calculations and they wait for the next job and then they start doing that, and there's nothing, no magic. They do one thing and only one thing. They're appliances. But because of that, and you'll see this also in the GPU realm, basically, they all have the same issues as routers. They don't get patched very often. They don't get a lot of fixes. They all tend to make really bad mistakes as far as like security concerns go. Like, they'll do things like they'll use the same keys for every image, and you'll find that every time you connect to a machine, it has the same exact fingerprint, which means that like any kind of communication you do with it, every time you remotely manage it, you kind of end up reusing keys, and then you leave yourself open up to a man-in-the-middle attack where people could, hijack your own keys on your own laptop and start authenticating themselves against another server or your own servers. That's like the absolute worst case scenario, and you have to mess a few things up to get that one. But everything runs as root. Like, it's game over the moment anything gets compromised in these things. Like, malware runs rampant, and I don't think that very many people know about it. I think just last week there was like a news article somewhere basically saying like, oh, our ant miners, like, they got ransomwared. Did anybody hear about that? Yeah, it's like, great, you bricked a bunch of ant miners. Like, what does that achieve? Like, wouldn't it make more sense to just divert them and steal all the money? Like, great, you announced your presence. That's the worst case scenario. That's why there's a news article. So you have to think, how many people are, writing Office Space worms and collecting, with just like 1% of 1% of everyone's mining power? We'll never know. You'll never know. Not unless you have like instrumentation and monitoring and are actually paying attention to like all the processes, like real data centers do. But you can't, because the mining firmware is closed. Like, it's designed and shipped to you, the consumer, as like an all-in-one solution. You rely on the manufacturer to patch it and make updates and make changes and secure it and lock it down. You're tied to it, and it's a very hostile environment to try to fix anything. We'll skip all those slides. And the other thing is like, so I'm somebody who like saw the problem being like a sort of back-end, front-end developer, and like went straight down that rabbit hole, getting into like firmware development, and it was intense. Reverse engineering is not a fun job. Unless you like puzzles, and there are people who like puzzles. But like you ship it out, you get everything going, and then like a new version of the miner comes out, and you're like, oh well, that's great. I'll just restart all of my work. But the other thing is like when you're mining for yourself, it's advantageous to you to keep it all to yourself. It's a very selfish industry, and I think it works so well because of it. Like, it's a lot easier to steal someone's earnings than it is to like double spend and tank the whole network. Like, I think that like far more people are incentivized to steal from miners because like at the end of the day, they usually kind of wash their hands of it. They're like, oh, it's okay. It was only a day of operating. We'll make way more than that. And so I guess like it kind of like brings this philosophical question that I like to talk to people about, which is like, is this a necessary side effect of mining? Like, is there something that like we as a community, as like an industry, as developers can do better, or is this kind of something that we have to accept, that mining works so well because it's competitive, that it needs, for it to thrive, for it to do everything that it's supposed to do as proof of work, that it has to be terrible in all the right ways. So I definitely, and before that, I guess like, I don't know why I thought this was the closing, because it was like perfect. We'll segue into that later. But I definitely encourage everybody to come talk to me. I would love to hear your thoughts on that as well. But before it's like all terrible and all bad and everything, I just want to real quick talk about how we can mitigate and fix that for your own operations. So one of those is you need to be more restrictive than a typical data center. Like, you need to make sure that all of your traffic is closely monitored, or at least blacklisted. You need to, because they're appliances, because they only communicate over one protocol, Stratum, it makes it very easy to secure a network. And you'll find that not many people are doing this. Just blacklist everything. If it goes outside my network, don't let it. It's one protocol, and you can whitelist things on like a port basis and like the most granular sort of like coarse way. Or you can do what we do, which is we use a proxy. So rather than making hundreds of connections outside of your network, you make one. Rather than having all of those miners connect outside of the network across the world to a random server, you make one connection to a server in your facility, and only that server is allowed to leave the network. That's how you solve 90% of cases of people stealing your funds and things like that. Just make sure that none of your miners can get out in the first place. Operate everything internally. Like I am especially crazy about this one. We've worked really hard to make sure that our own systems are locked down on this. I was saying earlier to somebody, I was like, our mining rigs don't even get access to time servers outside of our network. We run everything internally. We run, not just DHCP and friends. We run DNS. We run NTP. We run syslog. Everything stays internal and it doesn't go outside. And we play with it from there. It's very easy to set all of these things up. This is Linux System Administration 101. People don't do it as often these days because it is one of those things that is time consuming, or there's a lot of nuance and things to it, but it's still very easy to do. But centralized logging is going to fix 90% of it. It's also going to be your monitoring. Anomaly detection, things like that, looking for events and triggering and things like that. This is how we figure out when it's time to go fix a cabinet. So we see, oh, this whole cabinet went down. We just got 0 graphs per second being reported by Grin miner. I'm like, all right, well, someone should run down there. Whoever's on call. The other one is intrusion detection. This one's more if you're in the higher scale and you figured everything out, and you're not babysitting your GPUs and things like that. ASICs, I would say, are a lot more accessible for this kind of work. But intrusion detection systems basically consist of listening to log patterns and triggering notifications when things go wrong, or triggering some other action. So if you start seeing a bunch of authorization attempts and things like that, one really common one is called fail to ban. It's a simple project. A lot of people recommend it. It's a good enough out of the box support for just banning people whenever they try to just brute force things. If you listen to this talk, you're already blocking everything, so you don't need this as much. But Snort, Kismet, OSSec. These are a couple of them. I don't personally use all of these projects. I use Snort and some other things. And they end up being really good for detecting most things. Otherwise, log patterns. And that's it. I hope this helps.
Thank you, Ivy. You want one question?
Yeah, do we have time?
One. Yeah, good.
Okay. Yeah, and anybody else, please feel free to approach me. I'm all ears.
We have one good question for Ivy. One powerful question. Better be good.
So you mentioned one point of entry and exit.
Yeah.
But is that also obviously a single point of failure, or we can zoom in on that?
Yeah.
All your eggs in one basket kind of strategy.
Yeah. So the question was, when you have one point of exit, is that one point of failure? I'd say no. It's very simplistic. I'm simplifying it there. We do have multiple servers. We do have redundant links and things like that. But yeah, you want to have obviously multiple fallback pools. You want to have multiple nodes that can handle failures and things like that. But definitely that's the next step, right?
All right, thank you, Ivy.
Thank you, everyone.
Thank you. Okay.